That's like math. That thing.
Okay, and Global also.
Yes.
Union is here, this is nobody. Somebody. I just want to verify, because I keep forgetting, on Monday, please remember it's going to be a double period on Monday, not Tuesday. And as far as you can tell, you're all going to be here, correct?
Yes.
Is there anybody going on anything? Mock school or anything like that? Or Mock 3 or? Everybody's in me. That's pretty fast. That's right.
What did you say as far as you could tell because there might
No,
be snow there?
Ruth is not gonna maybe be here.
Yeah.
Why don't you say something?
You said
Well,
that.
I already discussed it with
I
you.
know, but I don't remember it.
Whoa,
So what was our plan B, if you don't get back in time?
I actually put periods next down,
And they are
period 2 and
So-
period 6.
period 2 and period
6.
6. So period 2, you would go to room 21. Mrs. Beck will have the test. Got it?
Period 2.
Yes. So if it's put off till that day, period 6, you'll come here. Okay? We're good? You just did attendance, yes? Did I just say sent? You don't know.
You could send it again.
I could, I want to. Let them come after me. Let's go. So, hold on. Oh, okay. Just talking to my computer. Today's lesson's a real, it's an oldie but a goodie. We're gonna do some polo stuff. I'll take one homework question. Is there a homework question? Yes. Quick.
Find the equation of the tangent line to the curve x equals e to the t and y equals e to the negative t at the point where t equals 2.
Okay. So, you said 2 t is to 2. So, I'm gonna write an equation of the tangent line, yes? To need the equation, I need the point and the slope. And I'm gonna use point slope form. The point is when t is 2, the x quantity is,
E squared.
and the y quantity is,
E to the negative.
so I'm gonna start writing the answer to your question. Y minus e to the minus 2 equals something times x minus e to the 2. I'm almost done. I haven't done anything. Certainly haven't done any calculus. So far so good. What's missing?
The slope.
The slope we find by finding
The derivative.
which derivative?
dy dx.
That's the derivative. And we learned yesterday, or reviewed yesterday, that dy dx can be done by finding d blank over d blank, fill in d blanks. Everybody?
Over dx dt.
So let's find dy dt, it's not hard. So what's dy dt? And what's dx dt? I would just like to simplify this a little bit. E to the negative t in the numerator could be seen as, good. Does anyone know how I could write this?
Negative 2t.
Because I have negative already.
Two.
So is that true? E to the t times e to the t is e to the 2t?
Yeah.
So I just wanted to simplify it a little bit. And so now let's find the slope, that is the slope. When t is equal to 2, that would be minus 1 over e to the 4. I'm going to place that here. And we're finished. That is an equation of the tangent line when t is 2. Make sense? I'll say one more question? Yes? Yes?
So, the question is, okay, sorry, I have the exact question. So, sketch
Just kidding. Go ahead.
sketch the curve by limiting the parameter t and label its direction as increasing.
Go ahead.
X is equal to t squared and y is equal to 2 ln of t, and t is greater or equal to 1.
So there's two ways we could look at this. We could see that t is equal to plus or minus the square of x.
Yeah.
Maybe not so easy. or we could solve this. I think this would be better. So I'm gonna look at this as y over 2 equals ln of t. How do you undo the ln?
E to the y over two.
Equals two.
Say again, e to the.
E to the
Y
y
over
over two.
2 equals t.
So now x would be equal to t squared, and what would that be?
E to the y. E to the y.
E to the y.
So
Wait, why can't you make it y equals ln of t squared and then just make it ln of x?
Oh, that would have been a great idea. I didn't even think of that. I didn't even see it do that. That was so smart. Yeah? Genius. See it?
Yep.
And same answer, because this is gonna turn into y equals ln x also.
Which line was it?
Yeah, I didn't, sorry, I didn't see it.
So what was that?
Coefficient, exponent, question?
Also, if you did do it the other way, wouldn't you reject?
Problem is a plus or minus.
Yeah, but you reject it because it's kind of an element of a negative number.
15.
But it's not a number.
Well,
It's a variable. That's the problem. And x can be positive or negative, y can be positive or negative. That's why I wanted to avoid that. What else was there in the question?
Yeah, so label the direction of increasing t, and also I have a question, why does it need to say t is greater or equal to 1, or like in a couple of these questions, why does it need to have something about t?
So, if it does say t is greater than 1, it's because, I don't know why it has to be, because for this one, obviously it doesn't matter what t is. For this one, t could be 1/2, it doesn't have to be greater than 1, it has to be greater than 0 certainly. So that was a stipulation in the question, maybe it has something to do with how it's, direction, it's of increasing
So
parameter.
label the direction of
So if
increasing.
we start at 0, we're starting at the point 0, sorry, we're not starting at 0, we're starting at 1, we're starting at the point 1, comma, 0. This graph is actually starting at this point. Now, if you know what this graph looks like, why are you looking at me like that?
You said x and y is 1 comes 0, because when you.
X is 1, Y is 0. I just figured it out for you. When
When
t
t
is
is
1, you said t greater than or equal to 1.
No, yeah.
When t is 2, the x value, of course, is 4, and the graph, you know what that graph looks like, that ln of x
Mhm.
graph. It looks like this. And so for the next x here, the next y here, etc., it's going to be increasing towards the right. So you might look at this as a clockwise direction. It's kind of a stretch to call it that. So I would say increasing towards the right.
Okay.
That's the direction of increasing parameter.
Yes.
Yes.
I have one more question.
Okay, go.
X is equal to the square root of t.
I'm sorry, square root of 1.
Square root of t.
Okay.
And y is equal to 2t plus 4.
Good.
Find the second derivative.
Okay, so how about t is x squared, y is equal to 2x squared plus 4.
Okay.
And what was it?
It says without eliminating the
Oh, okay, what did you want to find? I didn't even hear the
The
question.
second derivative.
Okay, so let's find out. First derivative, dy dx, is dy dt, 2 over dx dt, 1/2 t to the minus 1/2. Is that okay? Because it's t to the minus 1/2, I'm going to put it up in the numerator.
Right.
And dividing by 1/2 is like multiplying by 2.
4 squared.
So it becomes 4t to the 1/2. Does that make sense?
Yeah.
When I'm looking for the second derivative, d squared y dx squared, I'm immediately writing dx dt in my denominator, so I don't forget it. Did you?
No.
Good. And now I'm going to find the derivative of y prime with respect to t. So it's 1/2 t to the minus 1/2. Looks like this t to the minus 1/2 divides out this t to the minus 1/2, we'll just get 4.
Or you can just get it, because then it says that t is equal to 1. So like,
What do you mean? Oh, at t to 1? Guess what? At 2 and at 3 and at 4 and at anything it's 4. Okay? Please pass up your homework.
So when it says that t equals something,
If you have a t, you would plug it in, but we don't have, we don't have to.
so you do everything normally and just plug in that t. Okay, thank you.
Okay, so I'm hoping you remember this. I'm going to go through this as rapidly as I can. If we can. Polar graphs are not in the form y equals, or x equal y equals, in the form r equals. R the radius, theta is the angle, And typically an equation will be in the form y equals cosine theta, sine theta, or something like that.
Yeah.
So the interesting thing and something that's different about polar form is, for example, if a point is 2, 30 degrees, radius, angle, and we plot it, we look for the 30-degree ray, here you are, about, and we travel 2 units along that ray. Remember this? So imagine we're seeing concentric circles here, and that's about where the second circle is. That's the point 2, 30 degrees. But you can name this point another way. If you were looking at this angle, which is, I guess,
2010.
here, it could be named on the 210 ray. What would it be? Yes. So it's exactly the same point, and we say that the naming of polar points, they're not unique. In rectangular form, if you plot the point 2, 4, it's one way to call it, but here you can name it an infinite number of ways. What's another way you can name the same point? Yes?
2, 3, 90.
And on and on. So that's going to become an issue we're going to see soon, where you want to name the point one way and it doesn't work. I'll talk about what that means. But if you name it another way, it works. It's a little vague, and I wanted to keep it that way. Okay. Negative, positive, not unique. We did that too. So let's go to one of the easy ones, really easy ones. R equals 2. So you're plotting the point on your graph, and you're saying R is 2. All right, so theta is 0, R is 2. Theta is 1 degree, R is 2. Theta is 10 degrees, R is 2. Not even a theta in the equation, obviously it's a circle whose
Radius is 0.
and whose
Center is 0.
So we all call the origin called the pole, and that's it. There's another kind of circle as well. Circle in the, by the way, we can get back to that one. What if it was R equals negative 2?
Same.
So true. So if I were to graph this, R equals 2 cosine of theta, it also is a circle. I want to just talk about what it looks like and why it looks like that. What's the greatest value R could be?
2.
And it happens when theta is what?
0.
No.
Zero.
When
Zero.
theta is
Zero.
what?
Zero.
Zero.
Because when theta is 0, cosine of theta is. So imagine that's the second ray. Now that's 1 point on the circle. If you pick an angle 45 degrees, what would be the value of R?
1 over.
Try again? Say again?
Square
2
root
over
2.
2 over 2 over
2 is or just square.
Just square root two.
So the square root of 2 would be a better answer.
Yeah.
Yeah, you could use the form square root of 2 over 2 times 2.
Yeah.
Square root of 2 is about
1.4.
So that would be somewhere over here-ish. And at 90 degrees, cosine of 90 is? So in fact, it's come to 0. A semicircle has been created just from 0 to pi over 2. If you went to 135 degrees, now what's your answer?
Negative. Square root 2.
So negative 1.4-ish, so that would be backwards here, about over there. And when you get to pi,
It's going to be 2.
it is?
2.
No,
Negative two.
it is. Pi ray negative 2 is over. The circle is in fact completed in only pi radius. Go to 2 pi, just goes on top of it, so you get it repeats. Make sense? Maybe you remember this. If I insert a negative here, it changes something. Ruth,
It's reflected over the wire.
good. It's not called the y-axis anymore. This is called the polar, no, this is actually the polar axis. And this other one is, we'll call it the vertical axis, the axis with no name. That was a great description. If I changed it to positive 5 cosine theta, what would it look like?
But 5. Radius of 5.
No.
2.5.
It's not the radius of 5. Yes. In fact, this number isn't the radius, it's the, yes, try to remember. You can see the diameter was 2, originally. So if I change it to r is equal to 3 sine of theta, just a review, it does change it.
The radius, oh sorry, it'll just be above the above the polar axis.
That's correct. And what's its radius?
1.5,
Good. What's its diameter?
3.
What's its center? In polar form.
One,
1.5, 9.
That's correct. 90 degrees. Good. So it is 1.5 up on the 90-degree level. Ready? Okay, so that's all we've done, the old stuff, yeah? Most of today's lesson is going to be that way. I'm giving you a point, -2 comma 2 pi over 3. Because this is already listed as 2 pi over 3, you would assume it's polar form. If I said 2 comma 5, you wouldn't know. Because it could be 2 on the 5 radian ray. You would have to be told that that's rectangular or polar form. This you would assume is polar. Could you write that please into rectangular form? There was a way to do that. Anyone recall?
Oh, this
Or
side.
cosine.
No.
Sorry, x equals
R cosine
the
theta.
right answer, and y equals
R sine of theta.
Very good. So please just use the r and the theta from the question, and let's get its x and y coordinates. X,
Oh, X coordinate, never mind, sorry. X, yeah,
Rich,
So the x is -2 cosine of 2
little
pi.
louder.
-2 cosine of 2 pi over 3.
X is -2 cosine of 2 pi over 3, and you have to figure out what it equals. Cosine of 2 pi over 3 can't be 2 pi over 3.
I didn't say that.
What did you say?
I said the cosine 2 pi over 3. I didn't know you wanted us to simplify it.
I want to know the answer. Dangnabbit. If you're struggling with the cosine of 2 pi over 3, that's a problem. Reference angle is what?
16.
You know that. It's in which quadrant?
Second.
You know what cosine is in that quadrant. Yeah? The answer?
1.
For the y coordinate, now it's sine of 2 pi over 3. What's its SIGN?
Positive.
That is correct. So it's -2 times the sine of that same reference angle. So what is it?
Negative square root of 3.
Now it was over 2, but we multiplied by 2. Release? When you give a rectangular form, you have to convert it into polar form. It's a different pair of equations. Does anyone recall those?
Yeah.
One of them was
Tan theta.
very good equals,
X root.
close. Let me just explain why. So imagine you have that's a polar graph, and here's some angle of theta radians or degrees, whichever the case may be, and that's its distance. I'm going to call that distance r units along that theta ray. How would I get its component parts? This distance here in this little right triangle would be the x, this little guy would be the y. Clearly the tangent of theta is y over x, yes? The other equation that we need comes from this little right triangle. Jason?
X squared plus y squared equals y squared.
So there are 4 equations you need for this conversion process. So if I gave you the x and the y, it would be not such a big deal to find the r, and it would not be such a big deal to find the theta. Let me give you an example. Suppose you have a point let me make this -1 squared root of 3. That's in your rectangular form. You need to find theta, and you need to find r. -1, -1, -1, minus 1. I know it came out sloppy. Sad. We're almost done with the lesson. A couple more little things. Tomorrow we're going to graph 1,000,000 curves. I gave you the graph paper. Yes, the pole graph paper yesterday? So you should have a question. That's the question. Told you.
Can there be more than one angle?
Yes. What's the other question? Should be another question. What about
Plus or
our?
minus?
Yes. Which is it?
Both.
Either, not both. Either is okay. Let's discuss it. So, let's find r. R squared is equal to,
Oh, well, 1 squared.
1 plus,
3.
so r is equal to,
Plus or minus
Plus or
2.
minus 2.
it does. We're gonna have to decide which one to use. Let's get theta. How do we get theta?
10
Y over theta
Equals-
negative square root
Oh, sorry.
Negative
No,
square
negative
root.
square root.
So I'm gonna write it up one, just make it a little more familiar. Oh yeah, that's from the,
30, 60, 90 triangle.
thank you. And what must the reference angle for theta be?
2 over 3
60 was correct, or 5 or 3 is correct. Let's do it in degrees. But it's not 60 degrees because it's negative. And the question is, and that was your question, which is it? And it matters. Here, it can't be either one, it can only be one of them. It can only, which two quadrants should it be able to be in?
Second and third.
Four.
Second and fourth.
Second and fourth.
But it's not, it's only in one of those. The way you determine it is by
Oh, yeah.
plotting this point in rectangular, plot it. Which quadrant is it in?
Second.
So forget the fourth. So if you were plotting it correctly now in the second quadrant, and the reference angle is 60, obviously theta is,
120.
so for that 120, and you're over here, right? You know, negative 1 square root of 3, what's the other? Good. I said you could have used the negative if you went on the
300.
fourth quadrant angle, but then you would have to use the,
Negative.
no reason to do that, but you could. You just want to be ornery. Okay? This will be a great answer to the question. So I'm going to present a strange question, one that I did not present last year. I don't think I did anyone last year. To you. And just maybe someone will remember. If you don't, it's okay. R squared is equal to 4 cosine of theta. No, actually, it's nothing. There was a curve when it was a 2 theta. Anyone remember what that one was called? It was an R squared. The only with R squared. And it was
Oh,
there was a
with
2
the-
there.
Lemniscate.
That's what it was called. This is not a landscape, it's not a 2 theta. But the question is as follows. I'm thinking of a point, 2 comma pi, and the question is that point contained in this curve, whatever this curve is? And obviously, what would you do to test that? You would plug it in. You wouldn't take the time to graph it, you just see if it works. So plugging in for R, you get,
4.
plugging in for the cosine of pi, you would get,
Negative.
yes or no?
No.
2 words.
Negative.
So your first impression should be, nope, that's not a point on this curve. But in fact it is.
We just R can be plus or minus. and
No,
R squared.
R is 2 in this question, it's not plus or minus. 2 is not 2 or minus 2, 2 is 2. This is a point on the curve,
So that's to do with graphing at a
Nope.
different time.
maybe,
So when you
yeah.
Because if the point was -2 and 0, degrees, then
So
it'll
you're
work.
naming it a different
Yeah,
way.
but it's
Is it okay to name it a different way?
Yeah.
no.
Brilliant.
Awesome.
Let's see if that one works.
Yeah.
If the angle is
Works.
0,
It's 1. Meaning 1
4.
times 1.
negative 2 squared, 4. Very good. So sometimes you may have to alter the name of the point because there's a million ways to name the point. And you could find that that's the case. It does. Sometimes the answer is no, but that one was. Show that is our last question for today. Maybe. Show that 1/2 3 pi over 2 is on r equals minus sine of theta over 3. Yes, ma'am.
That's polar.
Pardon me?
That's polar, right? Yes.
Once you see an angle that's clearly named with 3 pi over 2, for sure it's polar. Yes. If you see the degrees or there's a pi in it, it's only if it's just two numbers. One of the numbers could be radians. This for sure is radians. Try it, see it plugs in, see if it works. Play around with it if it doesn't. Did I? It was
It does work?
What?
It does work?
right away?
Well, not right away, but
Ah.
it does.
So what do you have to do?
If you made the point, if you gave it in the form -1/2 pi over 2 and then plug it in, then
Is
you
that the
got
same point?
Yeah.
And then,
and then you got -1/2 equals -1/2.
make sense?
Yeah.
So you would have to, if this were a question on the test, you would have to show your other point, plug it in and show the left side equals the right side.
Yeah.
Did I give you an outline for the test?
Yeah.
So we do. You're gonna need polar paper probably for tomorrow, so bring it in.
Can I?
John, John,
Thank you.
John, give me your phone.